What if the most important message humanity is receiving right now is coming from a machine built before the internet? What if that machine is drifting so far from Earth that even light needs almost a full day to catch it? And what it is finding is forcing scientists to rethink the edge of our own cosmic home. And if you love stories that make space feel personal, tap like, subscribe, and share this video with one curious friend before we go deeper. Because what Voyager is telling us deserves far more attention. Voyager 1 is not new, it is not sleek, it is not powered by modern magic. It is an aging spacecraft launched in 1977, a time when personal computers were rare, the internet did not shape daily life, and almost nobody imagined that one small machine would still be talking to Earth nearly half a century later. Yet here we are. While most of us sleep, work, argue, scroll, eat, and move through ordinary life, Voyager 1 keeps going. It keeps moving through a region no human being can visit, and it keeps sending signals across a distance so huge that the numbers almost stop feeling real. That alone would make it one of the greatest engineering stories ever told. But that is not the part that matters most. The real reason Voyager 1 matters is not simply that it survived. It is that it crossed a border no other active human-made explorer had crossed before, entered interstellar space, and started reporting back from a place we had only tried to understand, from the inside of our own solar bubble. And what it has found is not the quiet emptiness many people imagine when they think about the space between stars. It has found structure. It has found motion. It has found a faint and persistent hum in interstellar plasma that gave scientists a new way to measure the environment beyond the heliosphere. In simple terms, it found that the darkness out there is not dead silence. Now, before we go any further, we need to be precise. The title says, NASA confirmed Voyager 1 found something impossible. That does not mean the spacecraft discovered a broken law of physics, a supernatural object, or some giant secret NASA is hiding in a locked room. The word impossible matters here in a different way. It means the data coming back from Voyager 1 showed scientists that some of their expectations about the space beyond our solar system were too simple. It revealed behavior they could not directly measure before. It opened a window where, until then, we mostly had theory. The impossible part was not that nature broke the rules. The impossible part was that an old spacecraft with limited power got far enough, lasted long enough, and stayed healthy enough to tell us our picture was incomplete. That is what makes this story so powerful. It is not about flashy science fiction. It is about reality being stranger and richer than the clean version we once drew on paper. It is about a machine built for a short mission refusing to become irrelevant. And it is about the fact that some of the biggest discoveries in science do not arrive with explosions. They arrive as weak signals, delayed by billions of miles, waiting for patient people to notice what has changed. To understand why Voyager 1 matters so much, we have to go back to the beginning. On September 5th, 1977, NASA launched Voyager 1 to explore the outer planets. The original mission was ambitious for its time, but still limited. Fly past Jupiter, fly past Saturn, take measurements, capture images, learn what we can. Then, eventually, the mission would end. Like many spacecraft, it was never expected to keep working forever. It was built for a specific era, a specific set of goals, and a much shorter future than the one it ended up living. Then, Voyager 1 started delivering. In 1979, it flew by Jupiter and gave humanity extraordinary close-up views and data from the giant planet and its moons. In 1980, it passed Saturn and deepened our understanding of that world as well. Those achievements alone would have secured its place in history. But the spacecraft did not retire. It kept moving outward, farther, colder, darker, stranger. Year after year, it continued to send signals home, even as the distance grew so large that every conversation with it became an exercise in patience. This is where the story starts to leave the normal scale of human thinking. Most of us judge distance by walking time, driving time, flight time, maybe the hours between cities. Space does not care about those units. With Voyager 1, even light becomes a slow messenger. A command sent from Earth can take about 22.5 hours to reach the spacecraft, and another 22.5 hours for a reply to return. In other words, a single exchange takes almost 2 full days. Imagine trying to diagnose a technical problem on an old machine when every question and every answer is separated by nearly a day. That is not routine engineering. That is remote surgery across the void. But before the engineering miracle, there was the geographic miracle. In August 2012, Voyager 1 crossed the heliopause and entered interstellar space. That sentence sounds technical, but it carries enormous meaning. The sun does not only give us light and heat, it also sends out a stream of charged particles called the solar wind. That wind pushes outward and helps create a vast bubble around the solar system called the heliosphere. Inside that bubble are the planets, moons, asteroids, comets, and everything else orbiting under the sun's influence. The heliopause is the outer boundary where the solar wind gives way to the interstellar medium outside. Think about that for a second. Voyager 1 moved beyond the protective bubble created by our sun and into the space between stars. Not to another planet, not to a moon, not to a nearby orbital zone, to the environment outside the heliosphere itself. That is why the mission feels so different from almost every other space story. It is not just far away. It is outside the familiar weather of our cosmic neighborhood. And why does that matter to us here on Earth, living under blue skies and streetlights and weather forecasts? Because the heliosphere is not just a scientific border. It is also part of our protection. The bubble formed by the solar wind helps shield the inner solar system from some high-energy particles coming from the galaxy beyond. That means the region Voyager 1 is measuring is not some random abstract zone with no connection to our lives. It is the outside environment pressing against the border of our home. When scientists learn how that boundary behaves, they are learning more about the larger space environment that surrounds and influences the solar system itself. For years, researchers had models of what interstellar space should be like. They had theory, they had calculations, they had indirect observations. But there's a difference between looking at something from far away and actually being inside it. Voyager 1 changed that. Once it was in interstellar space, its instruments began giving scientists direct measurements from a place no earlier spacecraft had sampled this way. That is the kind of moment science waits decades for. Suddenly, ideas that lived mostly in equations meet reality. And reality, as usual, had its own personality. One of the most fascinating findings associated with Voyager 1 was a persistent plasma hum detected in interstellar space. Research, highlighted by Cornell and published in Nature Astronomy, described a faint, narrowband emission that persisted from 2017 onward. This was important because, before that, scientists often relied on disturbances linked to solar eruptions to estimate plasma conditions out there. Those were useful events, but they were temporary and scattered. What Voyager 1 offered instead was something closer to a continuous whisper from the medium itself. That hum matters because plasma is not just a fancy science word. Plasma is gas whose particles are charged. It responds to electric and magnetic forces. It fills much of space. If you can track the behavior of plasma around Voyager 1, you can start learning how dense the interstellar environment is, how it changes across distance, and how it interacts with the outer edge of the heliosphere. One Cornell researcher described it in a way that makes the idea beautifully clear. Rather than waiting for a dramatic solar event, Voyager could keep saying, "Here is the density I'm moving through right now, and now, and now." That turns a rare snapshot into an ongoing report. That is the first reason the discovery feels impossible in the human sense. We were not supposed to have this kind of running commentary. From interstellar space, not yet. Not from a spacecraft this old, not with this level of persistence, and yet the data kept arriving. If this story is already changing the way you see the sky, hit subscribe, leave a like, and share this video with someone who still thinks space is just empty black silence. But the hum is only part of the deeper truth. The bigger lesson is that interstellar space is not simply blank nothingness. Popular imagination often treats the space between stars as a dead vacuum, a silent gap where almost nothing happens. Voyager 1 has helped push back against that oversimplified image. The interstellar medium may be thin, but thin does not mean meaningless. Sparse does not mean inactive. Over huge distances, even subtle structure matters. Magnetic fields matter, charged particles matter, density variations matter. The place between stars has texture, and Voyager 1 has been helping us feel that texture for the first time. This is why the mission has emotional weight beyond the numbers. It reminds us how often human beings mistake distance for emptiness. We assume that if a place looks dark and far away, there's nothing worth noticing there. But nature does not work according to our visual habits. The galaxy is not a painting. It is a living physical environment, full of fields, particles, pressure, and interaction. Voyager 1 is teaching us to stop calling something empty just because we cannot easily see it. And there is something almost poetic about the way this lesson arrives. It is not coming from our newest machine. It is coming from one of our oldest. In an age obsessed with upgrades, replacement cycles, and constant novelty, one of the most important scientific voices we still have is a spacecraft launched in the 1970s. It survives on a shrinking budget of power. It travels in darkness. It speaks slowly, and still it matters. That shrinking power supply is not a metaphor. It is a very real clock. Voyager 1 runs on radioisotope thermoelectric generators, devices that convert heat from decaying plutonium into electricity. At launch, the spacecraft had much more energy to work with. Decades later, that supply has dropped steadily, losing about 4 watts each year, according to NASA. That means mission engineers have had to make painful choices. To keep the spacecraft alive, they have shut down instrument after instrument over time. Every shutdown is a sacrifice. Every watt saved is borrowed time. Think about what that means in human terms. Imagine a team trying to keep the oldest working lighthouse on Earth shining through one more winter, then another, while carefully deciding which rooms must go dark so the beacon can survive. That is what Voyager mission management feels like now. It is an act of science, yes, but also an act of stewardship. They are not only running a spacecraft, they are protecting one of humanity's last direct windows into interstellar space. And then, just when the mission already felt fragile, Voyager 1 suffered a crisis that made the whole story feel even more unbelievable. Starting on November 14, 2023, the spacecraft stopped sending readable science and engineering data back to Earth. The signal was still there, but the information arriving was corrupted. Engineers at NASA's Jet Propulsion Laboratory had a living spacecraft that seemed unable to speak clearly anymore. After decades of successful operation, something deep inside the old machine had failed. The cause turned out to be brutally small. A single chip in the flight data system had stopped working properly. One damaged component inside a spacecraft more than 15 billion miles away was enough to break the flow of understandable information. It is one of those moments that makes advanced technology feel strangely vulnerable. All the distance, all the glory, all the history, and the threat comes down to one failing piece of memory. Now imagine trying to fix that from Earth. You cannot send a technician. You cannot swap a part. You cannot even respond in real time. Every test takes about 45 hours round trip. The engineers had to study the symptoms, develop a theory, send instructions across space, wait nearly a day for them to arrive. Then wait nearly another day to see the result. One wrong move could have ended the mission. One correct move could save it. And there was no fast feedback, no second-by-second dashboard, no luxury of trial and error in the ordinary sense. What the team did next deserves far more public admiration than it gets. They found a way to divide the affected code into sections and move those sections to different places in the spacecraft's memory. Then they had to adjust the code so it could still work as a whole from its new locations. They also had to update all the references pointing to that code elsewhere in the system. It was a delicate rescue operation performed by radio command on a machine older than many of the people reading about it. In April 2024, that work began to pay off. Voyager 1 resumed sending usable engineering updates, showing that the spacecraft could still communicate its health and status. That moment says something important about why this mission continues to fascinate people. Voyager 1 is not just discovering science, it is demonstrating a style of human problem solving that feels almost heroic. Quiet heroism, not movie heroism. The kind built from patience, caution, and technical imagination. The kind that says even when the machine is unimaginably far away, we will still try. And if you respect the kind of patience and courage it takes to listen to a signal this old, leave a like, join the channel, and share this with someone who loves missions that refuse to die. But the story did not pause after that recovery. In 2026, NASA faced another hard decision. On April 17th, engineers sent commands to shut down Voyager 1's Low Energy Charged Particles experiment, or LECP, in order to save power and keep the mission going. The instrument had been operating almost without interruption since 1977. It was not turned off because it failed. It was turned off because the spacecraft's power margins had become too thin, and the mission team needed to protect the remaining science systems. That detail matters. Voyager 1 is not collapsing all at once. It is being managed carefully through a slow narrowing of options. NASA has explained that only a few science instruments remain active on Voyager 1, including the plasma wave subsystem and the magnetometer. These are still sending back data from a part of space no other human-made craft is exploring in the same way. So the mission is in a strange stage. It is both dying and still scientifically alive. It is losing capabilities and still making history. NASA also described a plan with the memorable nickname, the Big Bang. The idea is to change how certain powered devices are handled, replacing some with lower power alternatives and trying to stretch the mission further. According to NASA, Voyager 2 was set to be the first test case for this approach in May and June 2026, with Voyager 1 possibly following no sooner than July if the tests went well, and there was even a chance that if the strategy succeeded, the LECP instrument on Voyager 1 might someday be switched back on. That is a stunning sentence when you really think about it. We are talking about engineers in the 21st century trying to squeeze extra life out of a spacecraft launched in 1977 so it can keep reporting from interstellar space. This is not just maintenance, it is the management of scientific time itself. Every extra month matters. Every extra stream of data is irreplaceable. Because here is the harder truth. Once Voyager 1 goes silent for good, the silence will not be quickly replaced. We do not have another new interstellar probe about to pick up where it leaves off. There is no immediate backup waiting on the launch pad. The spacecraft that opened this direct window into interstellar space is still one of the only tools humanity has for this exact job. When its signal stops, an era closes. That is why another official date in this story feels almost symbolic. NASA says that on November 18th, 2026, at 2:16:07 a.m. Pacific Standard Time, Voyager 1 will reach 1 light day from Earth. In other words, it will be so far away that light itself will need 24 hours to travel from our planet to the spacecraft. That will make Voyager 1 the first human-made object ever to reach that distance while still adding to its long list of historic firsts. Try to let that sink in emotionally, not just mathematically. 1 light day. A message sent from Earth on one morning would not get there until the next morning. If Voyager answered right away, you would not hear back until the day after that. We are used to instant replies. Voyager 1 lives on a completely different scale of time. It forces us to remember that the universe does not move at the speed of human expectation. And yet, even now, it is still in conversation with us. The conversation is thin, slow, fragile, but it is real. There is something deeply moving about that. Humanity has built many extraordinary machines. Some were larger, some were smarter in narrow technical ways, some were more expensive, some operated closer to us and produced richer images, but very few machines have embodied endurance the way Voyager 1 has. It keeps going not because it is invincible, but because it was built well, managed carefully, and supported by generations of engineers and scientists who refuse to let distance become defeat. The public often treats space missions as fireworks. Launch, drama, images, applause, and then attention moves on. Voyager 1 is the opposite. It is not fireworks. It is a candle that kept burning for decades longer than anyone expected. And because it kept burning, we can now see farther into a region that used to be almost entirely theoretical. That is a different kind of greatness. Quieter, harder to package. In some ways, more profound. Now let's return to the phrase, found something impossible. Because this is where the deeper meaning really lives. What Voyager 1 found was not a fantasy object. It found evidence that the interstellar medium has low-level activity and measurable behavior that can be tracked more continuously than many scientists once thought possible with the tools available. That may sound modest if you say it too quickly, but it is not modest at all. Science advances when reality becomes more measurable. When a place once described mostly by models starts producing direct, ongoing information, the whole conversation changes. Before this, scientists could often estimate interstellar plasma density through occasional events, especially shocks, tied to solar activity. Those events were useful, but limited. The persistent plasma emission detected by Voyager 1 suggested a way to monitor density more continuously. It turned interstellar space from a place we sampled occasionally into a place that could, in some sense, keep speaking. That is the breakthrough. The impossible thing was not a violation of physics. It was that the old assumption of near silence gave way to a subtler kind of signal. And that matters beyond academic curiosity. The heliosphere is shaped through interaction with the surrounding interstellar environment. If that environment has texture, pressure variation, and measurable structure, then understanding the edge of the solar system becomes richer and more complicated. The border of our cosmic home is not just a clean line in a textbook diagram. It is part of an active relationship between the sun's outward influence and the galaxy beyond. That idea changes the emotional meaning of the night sky. It suggests we do not live inside a perfectly sealed neighborhood. We live inside a bubble that exists in contact with a wider galactic environment. The edge of that bubble is a dynamic. Its outside matters. Voyager 1 is not just giving us trivia about some distant zone. It is helping define the conditions at the outer boundary of the system that contains Earth itself. If you want more stories, where science feels bigger than headlines, tap subscribe, hit like, and pass this video along before Voyager sends another message from the dark. There's another reason this story grips people so strongly. Voyager 1 carries the golden record. This gold-coated copper disc includes greetings in many human languages, sounds from Earth, music, and basic information about who we are and where we came from. It is not a practical data drive for modern communication. It is a symbolic object, a message in a bottle sent into the cosmic ocean. And that symbolism becomes more powerful as the spacecraft gets older. Because think about the contrast. On one side, you have failing chips, power cuts, and a machine living on borrowed electricity. On the other side, you have one of humanity's boldest statements of self-belief attached to its frame. The spacecraft may one day stop talking, but the record will keep traveling. Long after the last signal reaches Earth, Voyager 1 will continue drifting through the galaxy, carrying evidence that a curious species once looked up, built something delicate, and dared to send it beyond the sun's protective bubble. That is one of the reasons space exploration matters even to people who never read scientific papers. Missions like Voyager 1 are not just collections of measurements. They are expressions of a civilization's character. They show whether we are willing to invest in questions whose answers may arrive decades later. They show whether we can build for futures we may never personally see. They show whether curiosity can survive beyond the news cycle. Voyager 1 answers yes to all of that. And maybe that is why its current condition feels so emotional. We know it is old. We know the power is fading. We know instruments are being shut down. We know no machine lasts forever. But we also know that as long as it still speaks, it is still changing our understanding of reality. That creates a rare kind of tension, the kind that belongs not just to science, but to every meaningful human story. Something precious is still alive. Something fragile is still useful. Something near its end is still revealing new truth. There is dignity in that, more dignity than in 1,000 louder stories. It also says something humbling about how discovery actually works. The biggest revelations do not always come from the newest technology or the most expensive system. Sometimes they come from persistence, from extending a mission past its original expectations, from listening carefully after everyone else assumed the main story was already over. Voyager 1 is a perfect example of why we should be careful before calling any scientific journey finished. If engineers in the late 1970s had been able to see this moment, they might have believed the mission had already done enough just by visiting Jupiter and Saturn. They could not have known that decades later, people would still be studying its data to understand interstellar plasma. They could not have known that a one light day milestone would become part of its story. They could not have known that its survival itself would become one of the greatest arguments for long-term exploration ever made. And yet, that is exactly what happened. Now, step back and look at the scale of the lesson. Humanity is a species living on one planet around one star. Most of our history was spent not knowing what lay beyond nearby worlds. Then, in a shockingly short period of time, we learned enough physics and engineering to send a machine all the way to interstellar space. Not people, not a giant city-sized ark, a machine. Small, old, limited, stubborn, but enough to cross the boundary, enough to listen, enough to return news from the outside. That should change how we think about what is possible in the long term. Not because Voyager 1 proves everything will be easy, it proves the opposite. It shows that meaningful exploration is slow, fragile, and dependent on patience across generations. But it also shows that once humanity starts a journey, its effects can stretch far beyond the expectations of the people who launched it. We are still living inside the consequences of that 1977 decision. And maybe the most haunting part of all this is what will happen when the voice finally stops. There will be no dramatic explosion, no final camera shot, no cinematic goodbye. There will simply be a last signal. It will travel across the enormous dark for nearly a day. It will arrive at Earth. Engineers will record it. And then after that, nothing more will come. Voyager 1 will continue moving, but the conversation will be over. That future silence gives weight to every message we still receive now. Every data point from the plasma wave subsystem, every measurement from the magnetometer, every successful power-saving decision, every command sequence that lands safely after nearly a day of travel. We are in the final era of a living interstellar messenger, and most people do not realize it. That is why paying attention matters. Not because this mission needs sentimentality, but because it deserves witness. It deserves to be understood for what it is, one of the most successful acts of scientific endurance ever attempted. An old spacecraft, still working beyond the edge of the heliosphere, still teaching us that the galaxy outside our home is more textured and more active than a simple void. If this mission amazes you as much as it amazes me, subscribe now, leave a like, and share this video before the oldest explorer we have finally runs out of time. So what should we remember when we hear a title like NASA just confirmed Voyager 1 found something impossible? We should remember that the real story is better than the sensational version. The truth is not weaker, it is stronger. Voyager 1 found that interstellar space was not as mute as many people imagined. It found a persistent plasma hum that let